Tyson is having friends over for dinner. He starts preparing the meal at 3:45 p.m. The steps required for the dinner preparation are as follows. Choose the menu, peel the carrots, prepare the meatballs, prepare the sauce, cook the meatballs in the sauce with the carrots, prepare the salad, prepare the appetizer, cook the appetizer, prepare the dessert, set the table, serve the dinner, and end preparation. So the question is, will Tyler be able to complete all of the steps by 5 p.m.? Is it possible? Explain. Graph theory will help us to solve this problem. We start off with the first task, which is choosing the menu, and has an execution time of 5 minutes. We see that there are 2 steps that are dependent on A being completed, steps B and C, so they're going to follow after step A. We're going to connect them, and the weight of that, as we've said for step A, is 5. Now we look to see the next steps. We've got steps B and C. We want to see if any other steps are dependent on step B. So we look down this list, we see that step D is dependent on step B. So we slide it over, and we put in the connecting edge between B and D and give it its weight. So B also has a weight of 5. Now we look at step C. We look to see if any of the steps are dependent on step C, and we can see here that step G is dependent on step C, so I'm going to slide it out and also connect it and put in its weight. Step C has a weight of 15. Let's see if any steps depend on step D. We look down the column, we see that step E is dependent on D as well as C. So we can drag E out, and it's dependent on D as well as C, and step C has a weight of 15. Step D has a weight of 5. Adding in step F, we see that step F depends on step D being completed. So we can put in that edge and add its weight. Step D, as we've said previously over here, was 5. Now we've already got step G out here. G is dependent on C, as we've said. And there are 2 other steps we can see here that are dependent on G. So H and I are going to come after G, and we add G's weight of 15. We can add in step J. Step J depends on E and F. The weight of E was 45, and the weight of F is 10. Step K comes after H, I, and J. All 3 of those have to be complete before you can get to step K. J has a weight of 10, H has a weight of 15, and I has a weight of 20. And then finally, step L is simply dependent on step K being completed. And step K has a weight of 5. So we've created our map that represents this. Now we want to see whether it's possible for Tyson to complete his meal by 5 p.m. when he started at 3:45. So if we consider that time, first of all, from 3:45 to 5 o'clock is 1 hour and 15 minutes. Or we could also say that is 75 minutes. So in order for him to be able to complete that, the critical path through all of the steps required has to be 75 minutes or less. Let's take a look and see what each of the paths adds up to. 5, 10, 15, 60, 70, 75. So the red path fits into the time available. We start off again going A to B, B to D. This time, however, we're going to take the other branch that's available to us, go to F, and back to J, and to K and L. And the total weight of that path is 5, 10, 15, 25, 35, 40. Let's look at another path through. 15, 5 plus 15 is 20, plus 45 is 65, plus 10 is 75, plus another 5 is 80. So at this point I can say fairly definitively, so this path takes longer than Tyson has available. We're still not sure it's the critical path yet, however, so we'll check out the other paths as well. 5 plus 15 is 20, plus 15 is 35, plus 15 is 50, plus another 5 makes 55. And the final path, 5 plus 15 is 20, plus 15 is 35, plus 20 is 55, plus another 5 is 60. As a result, we can conclude that since the longest path through is ACE-JKL, which is 80 minutes, Tyson is not able to complete his dinner in the time available. So that is the critical path.